So let's actually see how this example looks in real life. Let's switch the model to healthy just to be sure. So it starts to create data. And in the notebook, we see data arriving, one dot for each sample. At the same time, we are using the dashboard functionality of the IBM Watson IoT platform in order to see what's going on. So we see real-time time series plots and gauges displaying the data. Later we expect anomaly score and alert to be populated. Remember, we've sent a no alert message to the UI in the notebook. Once the buffer is filled with 3000 elements, data gets sent to the neural network for training. This is called a count-based tumbling window. Other variants of stream processing windows are time-based or session-based windows. All of them can be tumbling or sliding, but we will cover stream computing in a separate course very soon. So now the window was full and was sent downstream to the neural network for training. It takes a little while until Keras and TensorFlow are started, and now training starts. During training we send the current loss upstream to the queue, so we should be able to see it in the dashboard. And as we can see, we've started with an anomaly score of 0.04 and are slowly getting down. This works as expected since we are looking at known and healthy data. Now training has finished and usually the next windows of data would have been processed. But we've limited the test data generator to 3000 events, so we need to switch to broken and reset. By the higher amplitude we can make out that the pattern of data has changed. But the cool thing is that with an LSTM autoencoder based neural network, we don't need to tell the neural network how healthy and broken data looks like. It finds out by itself. A bit scary, but totally awesome. And again, we need to wait until the window is full. So training has just started and we immediately see that an alert has been raised. This is reflected in the dashboard as well. And in addition, we see a clear spike in loss. But we notice as well that loss rapidly goes down since the neural network now gets used to broken data and sooner or later it considers broken data as healthy as well. Therefore, the system has automatically reset itself to the last known healthy state by reloading the pre-trained model from disk. Those warnings are due to the fact that communication with the message queue in the Keras callback handler takes some time, but we can ignore those. So this was an example of an end-to-end scenario. If we are happy with the solution, we could easily export the model to IBM Watson machine learning because running everything from a notebook for a production scenario is not a good idea. In a later lecture, we'll also learn how to make use of Apache Spark for parallel neural network training and scoring, so stay tuned.